Welcome to CS101, Introduction to Computer Science. This is the final class, the conclusion. Okay, so you've taken 2 to 3 hours of this course, Basics of Computer Science, and you're probably wondering, how can I learn more? So there's many options to continue learning computer science. There's a full computer science program in many colleges and universities. There's four-year programs typically, but you can do shorter programs at community colleges. There's online courses at massively online, open online course websites such as Coursera, Udemy, edX, Udacity, very much similar to what you're seeing today. And additionally, these courses offer additionally highly specialized training, so you don't have to do a full 4-year program. You can take courses in the language or programming language or course of your choice, and you can go in highly specialized fields and start learning on topics there. You can also go to coding schools. These are small schools dedicated to teaching the students real world programming that you'll use at your job. So I think of them as similar to driving schools or martial arts classes and things like that. You go into the school. It's dedicated to a short program where you basically learn the skills that you need for your job. You can also be self-taught. There's a whole bunch of self-taught programmers out there. There's a whole bunch of online websites and blogs where you can learn programming on your own, oftentimes for free. And many companies, specifically the big ones like Google, Apple, and Microsoft, will also provide free documentation on training if you are basically using any of their software or tools that they provide. So let me give you an example of a 4-year computer science degree that's offered, for example, at New York University in New York. So there's a whole bunch of core courses. This is what your typical 4-year CS degree would look like, right? I'm just using New York University as an example. So you have basic programming like in Python or Java or other languages, similar to what you saw today, except as a full course. There's math courses, some basic engineering courses, about 2 to 4 of those, humanities and sciences courses, about 1 to 3 of those. And there's data structures, algorithms, operating systems, computer architecture, software engineering, databases. So this is kind of similar to what you would see at other computer science programs as well. There's a whole bunch of foundational courses in engineering and math, and all these fundamental computer science courses as well, which give you the foundational knowledge you need to build more sophisticated software. Data structures, algorithms, and all these other topics fall into those. And then there's a whole bunch of electives as well. So once you finish the core, you typically have to take elective courses, and there's a whole bunch of those as well. So at NYU, they offer digital logic, which is for computer hardware, just thinking through how a computer processes digital logic. There's game design, for obviously game design. If you want to do parallel and distributed systems, there's a course for that. Unix programming, advanced Java, computer and network security, computer networking itself, cryptography, which is how to encrypt and decrypt messages that you want to send over a network, computer graphics, and artificial intelligence. So you get a whole bunch of core courses and electives, and these would take you 4 years or so to get this computer science degree, which has all of these as a foundation. So once you graduate with the degree, what's out there? So let's look at the job market and some descriptions. So you have a software engineer who actually builds the software and websites, right? Some companies have a position known as the senior software engineer or various levels of software engineer. Typically, these are just I've put here an older version of the above, just people who've had a lot of experience, working as a software engineer, and they become senior just because they've been working in the field for so long, right? There are project or product managers. What they do is typically facilitate team communication. Sometimes they are technical, sometimes not so technical. Maybe they can't program, but they understand the technical aspects of the project they're leading. And typically they're there to facilitate team communication within the team, outside the team. They communicate to stakeholders outside the team, and in general make sure that the team is functioning together and moving on course as required. Then there's tech leads. These are people who are technically strong and lead the overall design. They're also typically senior, but they have a little bit more of a leadership role on the tech side. There's also managers, tech managers, who lead the project itself. There's systems admins, who manage services and your servers that run for online services. Now, systems admins, also known as DevOps, well, that's not true. Systems admins are actually operations, and there's this new thing called DevOps, which is a bit of coding plus server administration. Typically, server administrators don't actually write code, or they write simple code in programming languages that are meant to keep your servers up and running and automate a lot of those tasks. That's what they do. A database administrator, similar to a systems administrator, manages databases. They architect and optimize databases for better functionality. Data engineer, this is a new sort of job description. They build software for data pipelines. And then there's data scientists and data analysts who actually analyze the data that's produced through these software and tools and try to find meaningful information from it. And then there are the people you hear about in the news all the time: entrepreneurs, founders, CEO. They start their own company, and in the context of this course, they typically start their own tech company, obviously, because we're learning computer science, and you can do that as well. So you might feel you might have gotten the entrepreneur bug, and you can definitely do this. Like, if you learn the basics of computer science, you will be able to start your own company and sell software that you make. So let's look at computer science and software companies. There's a whole bunch of software companies that are large and small. There's the ones that are often mentioned in the news: Apple, Google, Facebook, Microsoft, Amazon. There's large and kind of less they're still well known, but less featured in newspaper publications, I would say. Oracle, IBM, Twitter, Adobe, Intel. You've probably heard of all of these. And there's startups that are not quite startups because they've grown big, and they don't quite fit the startup mold, but they're not that big to be a giant company either. So these are kind of the not quite startups, is what I would say. And then there's a whole bunch of startups as well. So these are companies you may not have heard of. They're smaller companies. They're not public, but they are often providing a service that's used by many people. And these are all software companies. So they produce software, and they hire software programmers to produce software. But computer science and software engineering programming are heavily used in other fields as well. So we saw many examples in the first class. In finance, it's used for trading, compliance, data analysis. In healthcare, in journalism, and in entertainment, online advertising. So it's permeated the advertising field, and retail with e-commerce. As all of you know, Amazon is a pretty big, it's a software company, but it's also really a retail giant at selling products online. So computer science and software engineering have really permeated all fields, and it's hard to find a field that's not been affected by computer science so far. So even if you don't end up being in a computer science program, at least this is pretty useful for you to understand the basics of computer science and take it to whichever field you will be applying it in. So that brings us to the end of the class, and I hope you all enjoyed what might be your first introduction to computer science. You might have taken other courses before. This might be your very first class, very first dipping your toes in the water in computer science. It's not actually as hard as it seems once you get really more programming experience. It's all like about practice, just like all other fields. You understand the basic concepts, and then you apply it in practice. And there are always careers that involve computer science, but without programming as well. So whichever career you go into, like I said, the knowledge of computer science is very important there. So this hopefully this course helped you get some foundation in computer science, and you can take it to whichever field or career you work in. And if any of you ever do go into computer science or software engineering, or found this course useful in any way, please do drop me a note either on Udemy or over email. Not necessarily right now, but a few years from now, if things do progress and you end up being a computer scientist or learning some of the principles you learned in this course. I would love to hear about whether this course helped your career or life in any way. So that's basically it. Again, thank you for your time, and I hope this course was useful and you learned a lot about it, or at least, if this was your first introduction to computer science, I hope it helped you understand what this field is and what is going on there, so that you can take more advanced lessons and topics.